Okay, why don't we go ahead and get started? I see an excellent attendee list in the webinar this morning. So again, welcome to today's IWCS webinar. My name is Dave Cadu, and I'm honored to be the CEO and Director of IWCS. And I'll be your moderator for today's IWCS webinar series event. A few housekeeping items. Please note that as an attendee, you're part of a larger audience. So during the presentation, all participants will be in listen-only mode. And as a reminder, this event is being recorded for rebroadcast. We encourage you to submit your questions in writing at any time during the presentation using the chat panel on the right of your screen. After typing your questions in the space at the bottom, hit the send button and your questions will be monitored and addressed, time permitting, at the end of the presentation. Our webinar, IWCS webinar series event today is on industry trends and is hosted by Teknor Apex, a partner level sponsor of the IWCS Cable and Connectivity Industry Forum. Today we welcome David Braun, the industry manager for wiring cable at Teknor Apex out of Rhode Island, USA. David will be presenting his paper on the PVC Elastomers for evolving application requirements. He'll be providing Teknor Apex's perspectives on this very important industry trend of materials. IWCS is offering this new series of webinars on important trends and technologies from the perspectives of our supply chain technology leaders and sponsors of our IWCS Cable and Connectivity Industry Forum. Today, you will learn about elastomeric compounds in the market and how new and evolving wiring cable applications in electric vehicles, industrial automation, and portable power cables require more advanced material solutions. David Braun is the industry manager for wiring cable compounds. He came to Teknor Apex in February of 2015 with over 20 years of progressive product development, product management, operations management, and general management experience in the wiring cable segment. Most recently working for 8 years at Cable Components Group in Pawcatuck, Connecticut, and previously at NEPTCO in Pawtucket, Rhode Island for 15 years. David is an active participant in wiring cable industry organizations. He's a member of the IWCS Symposium Committee, and in 2012 served as the Symposium Chairman. He also participates on the board of the Wire and Cable Industry Suppliers Association, WCISA, and he holds 7 U.S. patents for electrical shielding, data center separators, and halogen-free compounding technology, and has been published in several industry trade journals. David holds an MBA in marketing from Braun University in Rhode Island and has a Bachelor of Science in Chemical Engineering from the University of Massachusetts in Amherst. So again, we welcome David to present at today's IWCS webinar series Industry Trends event. David, go ahead and share your presentation, please.
Thank you very much, Dave. I appreciate that. Is everyone, well, Dave, I guess I'll ask you, are you able to see my presentation on the screen? Hopefully, yes.
Yes, I can.
Great, terrific. So we're going to talk about PVC elastomers. There's a lot of evolving cable applications. David, thank you very much for the gracious sharing of my background. I'm excited to be here today to talk about Flexalloy elastomers. The agenda will be that we'll talk about our company overview at Teknor Apex, some evolution within the cable sector, elastomers in general, and then focus in on our Flexalloy solutions, things that we do to be responsive to our customer needs, and wrap up with questions. So an overview of Teknor. We are a privately held, family-owned firm founded in 1924, so it's almost 100 years old, and we're one of the world's leading custom compounders of plastics. The company started out as a tire retreader in Providence, Rhode Island, and is now headquartered in Pawtucket. We operate 13 manufacturing facilities worldwide in the United States, Belgium, Germany, China, and Singapore. And vinyl compounds are produced at 7 of these locations. We employ over 2,000 people. And as part of the company's commitment to innovation, we have established 3 applications development centers of excellence in the United States, in China, and in Germany. At these locations, we validate compound processing performance and properties in a broad range of industry applications. Here are the specific worldwide locations of our facilities and our application development centers and sales offices. We reflect the values espoused by our shareholders, and we put them in writing, and these are reflected upon regularly. The values are safety, respect, innovation, accountability, partnership, and sustainability. And these have guided us for many years, but especially through the challenging last 2.5 years. As you can imagine, in this time of challenges, partnership, sustainability, and integrity have been critical to guiding the way. The company is organized by core material technologies, and we have 6 business units. The vinyl division is the largest and also the oldest, with our initial products launched around 1948. Today, the primary products of the vinyl division, my division, include Apex flexible and rigid vinyl, FireGuard, low smoke, very highly flame retardant compounds, typically used for plenum applications, Flexalloy, which we will talk about, our vinyl elastomers, HalGuard, low smoke, halogen-free flame retardant compounds, as well as elastomers that are halogen-free, and our WeatherGuard rigid vinyl blends and alloys. The other businesses within the company are our Thermoplastics Elastomers division, which provides TPE, TPV, TPS, and TPO compounds. Our Engineered Thermoplastics division, which has a wide range of polyamides. Our Color division produces products of color and functional master batches. And our Chemicals division, which produces plasticizers and lubricants, with some of the plasticizers used internally in the production of PVC compounds. And finally, our Hose division, which is it manufactures garden hose. It's our only consumer product, and you have probably seen them in the big box stores as well as on Amazon. So the vinyl division is a global supplier to obviously electrical and electronics, which we're talking about today, but also to the building and construction, consumer, industrial, medical, packaging, and transportation industries. So we support a broad range of standard and custom applications within these sectors. And a little more information specifically about Teknor and wire and cable. I already mentioned the brands. In addition to the Apex flexible PVCs, we also have blends that are abrasion and oil resistant, very good at low temperatures, as well as the other sectors that I spoke of previously. So ever since the first telegraph lines were deployed in the US in 1844, communications and electrical cable technologies have evolved. The next slides will discuss some emerging applications and the properties that materials need to possess to support them. Now, electric vehicles. This is clearly a strong emerging trend. Worldwide sales of electric vehicles hit 6.6 million units last year, and that was double the previous year. Compare that, for contrast, to 2012, when the market was just getting started. At that time, 130,000 cars were sold. Now that amount is sold every single week and growing. Additionally, the US federal government is financing the growth of electric vehicles. And of course, the high price of gasoline is pushing us a little bit closer to electric vehicles more and more. Now, let's talk about the cables to charge these vehicles. They have multiple competing requirements. They need to be durable over many years of service. They can be used anywhere in the country, so they need to be able to handle summer heat and sun. and be flexible in all weather to coil and uncoil. They need to be aesthetically pleasing. A low gloss finish is generally preferred. They have to resist environmental contaminants like oil, and they need to stay flexible even when you're charging your vehicle in very cold wintry weather. Another sector is industrial automation. We've all heard of Industry 4.0, and that conceptualizes the rapid changes to technology, industries, and societal patterns enabled by increasing interconnectivity and smart automation. So in short, we're talking about smart processes that enable industrial automation, and cables form the backbone of industrial automation. The sector is expected to grow 9% per year over the next 4 years, according to Mortar Intelligence, and there's all kinds of innovative cable designs. So an example would be the need to combine electrical power of up to 600 volts or even higher, along with data pairs or optical fiber in a cable that provide two-way information connectivity. And it has to be flexible so that robots and drag trains can handle it. The jacketing material used on custom cables like this critically affects their flexibility. PVC elastomer jacketing imparts high strength, greater flexibility, fire safety for indoor use, and longer lifespan than many other materials. And then portable power. There's been no shortage of weather disasters in recent years. Disaster relief responders make great use of portable power delivery. The cords need to be heavy duty to cover long distances and variable weather conditions and possibly being run over. Flexing, exposure to sunlight, exposure to broad temperature ranges, and in some cases oils, all of those lend themselves to use elastomeric materials like Flexalloy. Let's talk generally about some of the choices that are available. I'll stay specific to Teknor Apex. Teknor Apex offers the following types of elastomers for the wire and cable applications. Our TPE division offers Elexar styrenic TPEs, which are easy to process and have low specific gravities with broad temperature ranges available. For some applications, there's drawbacks like limited flame retardancy and oil resistance, but not all. We also offer a halogen-free version of a styrenic TPE. These are known as HalGuard E. They're designed with flame retardancy and some oil resistance suitable for appliance wire applications. Now shift over to the next box. Another type of TPE is olefinic TPEs. Our TPE division offers this under the Telcar trade name. These are lower cost materials, and they have good moisture resistance and can also be halogen-free. For many applications in wire and cable in particular, the FR and fluid resistance performance may not be what is needed for the application. So that leads us to PVC-based elastomers sold under the trademark Flexalloy. Keep in mind how versatile PVC is. Flexalloys are available at different price points depending upon their formulation and performance. Key attributes, which we'll spend more time on, include high flame retardancy, excellent oil resistance, UV resistance, and flexibility. These are PVC based, so that means that they offer the highest flame retardancy of the elastomers listed here. So what are they? What are Flexalloy compounds? They are PVC-based elastomers that provide toughness and resilience to the point that they can meet critical performance criteria such that they qualify as TPEs. They meet the elevated temperature, heat shock, and heat deformation tests that UL requires for TPEs. These are an excellent alternative to cross-linked rubbers, and they are recyclable. But like most rubbers, they are available in a matte finish. They can be formulated to meet a wide variety of applications, and we'll talk about specific compounds later on. But we can combine brittleness temperatures below -60 with an oil 2 rating and FT4 flame performance in an industrial tray cable jacket. That's a pretty tall order for most other TPEs on the market. And Flexalloy is more cost-effective than many other TPEs available. So what about processing? right? It's got all this high performance. How does it run? Well, fortunately, Flexalloy compounds are processed to run on standard PVC equipment. There's no need to retool. The only adjustment that's required is to increase the extruder temperature to compensate for the higher melt point of these compounds, which are formulated with ultra-high molecular weight PVC. Aside from that, these are readily run on standard PVC equipment. What about UL recognition? It's something that in a previous webinar we talked about. It's very important to have that available. Well, we have numerous grades of Flexalloy insulation and jacketing compounds that are UL recognized for use in wet and outdoor locations, and they're capable of meeting requirements such as UL 13 for power limited circuit cables, UL 62 for flex cords and cables, UL 1424 for power limited fire alarm circuits, and UL 1277, which is electrical power and control tray cables with optional optical fiber members, basically control cables and factory automation cables. All right, so going back to applications, and what Flexalloy would we suggest for what need? Well, let's take a look at those same applications. First, want to offer a couple of insulations. We do offer more than this, but for the purpose of this presentation, we wanted to focus on these. Flexalloy 89504-90 and its more flame retardant sister compound, the 90FR, are both 105 degrees C rated UL QMTT2 recognized insulations. And they're available for use for THHW PVC cables. They offer oil 1 and oil 2 resistance. They are VW1 rated, which is a small scale flame test. And the 90FR version additionally is 720 hour UV rated as an insulation. They are also UL recognized to 75 degrees C as thermoplastic elastomer wet location compounds at a minimum thickness of 31 mils or 0.78 millimeters. And the relatively high hardness of 90 Shore A, it provides good abrasion and crush resistance. And since they're PVC-based elastomers, they are able to be recognized as both PVCs and TPEs. Going on to the jackets. For EVE jackets, we suggest 3 compounds for consideration. The first column, 960272FR, it's a workhorse compound with a minus 48 C brittleness temperature. The next one over, 961275 LG for low gloss, is our lowest temperature EVE compound. It's got a brittleness temperature of at least minus 60 C. And then Flexalloy 9615-80 is a bit harder. It offers greater durability and a brittleness temperature in between the other two. So you've got some choices depending upon how you want to make the design of your cable and the performance of that cable. For rapidly emerging industrial automation applications, we suggest 3 jacket compounds for consideration. The 960272FR, you've already seen as a workhorse compound. 960570FR is even more flame retardant with a typical LOI of 30% for cases where the cable core material may be somewhat more flammable, right? It's always the whole cable design. You need to take into consideration how all the different components balance each other. Flexalloy 9618 offers the highest flame retardancy at 33% LOI, along with a brittleness temperature measured of at least minus 60 C for cables that need to pass very low cold temperature impact tests. So a good range of products for different applications. Now, portable power cables. These are typically used outdoor. They do not need to pass the large scale flame test needed for control cables. So slightly less flame retardant jackets are appropriate. They still pack a punch on performance. The 960272 is more economical than the 960272FR we discussed in the last slide. And Flexalloy 960665 offers very low temperature brittleness along with a very soft 65 Shore A delayed hardness. These products are excellent choices for cables that need to perform well at low temperatures and be continuously coiled and uncoiled. So shifting on to talking about the development resources that we offer. Teknor Apex is a custom compounder, and our scientists innovate using the resources of our analytical lab to help them understand the components of a compound. They use our physical testing and our quality control labs to characterize critical compound attributes. And our applications development lab, where we extrude cable insulations and jackets, helps us identify optimized processing conditions and tooling so that we can pass that on to our customers. And in response to ongoing raw material shortages, we have continued to innovate and have developed 3 new compounds that are intended to be more readily available while some material shortages continue. So these are, These are analogous compounds to the ones you've seen earlier. They have very low brittleness temperatures with similar LOIs, and we haven't given up on the oil resistance. The data shown are pilot runs and are very promising, but our 5960272, our 5960272FR, and our 5961580 are excellent choices as we continue to move through this challenging environment for raw material runs. So we offer these products for your consideration. Now, Teknor Apex has a regulatory department which is very busy. They provide product stewardship for the compounds we make. Global regulations are constantly changing, and it's essential that we track what is new around the world and ensure that we are always in compliance. One note about many of these regulations is that we call out regulatory issues on our SDS sheets, so it makes our customers' research easier. Oftentimes we'll get requests, hey, is this RoHS compliant? Is it compliant? Is it free of heavy metals and SVHCs? Oftentimes a special regulatory request becomes unnecessary because all the information that you need is already spelled out in the SDS. And then finally, to share some more information, we've got upcoming events. In 2 weeks, we'll be exhibiting at Wire Dusseldorf. If you are there, please stop by. And even more importantly, do not miss attending the sponsor of today's forum, the International Wire and Cable Symposium. The symposium this year will be held in person, October 10th to 13th in Providence, Rhode Island. In addition to being the premier technical conference on copper and fiber optic connectivity, Providence boasts some outstanding restaurants that you really need to check out. So please join us at IWCS this fall. In the chat, we've posted some further information on today's discussions. And of course, you can always visit our website or contact us directly. I'll be showing my contact information later. So basically, to wrap up before question and answer, I hope to have enhanced your knowledge of our capabilities, our expertise, and broad range of wire and cable applications, especially elastomers, and our ability to support customers with standard and custom compounds for the applications. Whether you need help with a new project or resolving challenges with an existing product, please contact us and we will work with you and our technical team to solve the problem. We are successful when you are successful. So with that in mind, here's my contact information. Thank you very much for your attendance. I'm happy to take questions at this time. Dave, please take it away.
Well, thank you, David. Very informative and vital information on evolving products for a lot of important applications in our industry. I do remind everyone that if you have a question for David, please type that in the chat function. And again, we'll go ahead and pose those questions. And we have Becky from IWCS, our producer, who will help me monitor in case I've missed any questions. But David, important, interesting question. Why would you rather not have halogens in your plastics? Or I think the better way to ask the question is, what are the benefits of halogenated solutions versus non-halogenated solutions?
That's a big one.
It is. It's that's a
I'd love to
great
refer to
question.
one
That
of your
could
presentations.
take another presentation.
So, halogen-free has a very interesting place in the world. Keep in mind that a halogen-free polymer is a polymerized form of petroleum, right? So its flammability is very similar to candle wax. And so to make a halogen-free compound flame retardant, you need to add a lot of flame retardant to it. And that can have impacts on its physical performance. But on the other hand, when it does burn, although it gives off carbon monoxide, as all combustion products do, it will tend to give thin smoke. The smoke is not very acidic. And so in some cases, it buys you some time to get out of the building. You have some visibility. And for that reason, it's used oftentimes in subways and on shipboard applications. And in some jurisdictions, halogen-free is preferred. In North America, a lot of times I think we've taken a different tact, which is let's make sure that there are no fires that spread from room to room due to a cable, which may be stretching from room to room. So PVC, which contains chlorine, is inherently flame retardant, and it compounds very well, very effectively to become even more flame retardant and very low smoke. So you can and as I mentioned many times already, it's very versatile. So you can affect its flexibility, its indoor-outdoor life, the temperature ratings, the UV, all the things that you would need to affect. As far as any philosophical underpinning of halogen versus non-halogen, I would say that what we try to offer is a solution that meets our customers' needs. And if they prefer non-hal, we have an outstanding line of HalGuard halogen-free product compounds, which were originally designed to meet tough North American flame standards and do a great job at meeting European CPR standards, the very high ones like B2CA and CCA, as well as North American standards like RISER and FT4. So really, it's two different types of compounds, two different performance profiles, and both of them have a place in this world today.
That was an excellent answer to a very complex question, and clearly we're all about the balance of performance, safety, sustainability. There's just a delicate balance that has to be maintained, and I think that's what dictates the solutions. And we try, I think as an industry, we try to, again, look at the correct solutions as opposed to trying to bias one way or another, halogen free. You're really just looking for the best engineering perspective on formulation. So another question, would a 9602-72 flame retardant jacket have the same look and feel as a PVC? What's the comparison of a PVC versus elastomeric?
Yeah, very good question. Yeah, these materials look and feel like PVC, other than that they have high heat deformation characteristics. We do offer them in glossy, and some people prefer them in glossy, but some compounds are preferred to be low gloss. Even though they feel like PVC, it makes them look a little bit more like rubber. But I would say that to most customers, if you say, hey, this is a TPE cable, they say, yes, it is. If you said, hey, this is a PVC cable, they'd say, oh, yeah, I believe that. So there's really no significant difference other than perhaps the gloss level and the flexibility. The hardness is highly variable, but we can tune that in. In the case of that particular compound, it's a 72 Shore hardness.
Good. Are there any UL94 V0 HalGuard products available today?
There are, yes. Many of the HalGuard products meet ULV0 at 1/8 of an inch, and some meet it at 1/16 of an inch as well.
Good. Is the specific reason you named this PVC elastomers is because it meets both PVC and TPE specs, or is it because it contains non-PVC elastomers in order to meet both PVC and elastomer specs. If you kind of understand the conundrum there, they're both PVC and elastomer specifications. So try to explain, how you make, why you make the connection specifically.
So that's a good question, especially when we call it Flexalloy. So it kind of implies that there is some other resin in there. But let me say this: Flexalloy is a fairly wide tent, and the key attribute to the Flexalloy is that it is going to meet the UL specification as a TPE. There are, in the Venn diagram, UL TPE is also a fairly large tent. And that's the one that contains, a wide variety of other materials, some of which I mentioned in this slide, like the styrenics and the olefinics, TPVs, TPUs. There's a variety of materials that all fit within that tent. This one happens to be PVC based and meets the requirements of TPEs. Whether or not Flexalloy is blended with other resins, it can be. I would say that some compounds are and some are not. And they provide different properties such as chemical resistance, thermal resistance, cold temperature bend. All of those things can be fine-tuned depending upon how it's formulated with or without additional compatible resins in the same compound.
Very good. Do you have a Flexalloy compound to replace CPE compounds for jacketing applications?
One of my colleagues, John Mello, is jumping up and down saying, "Oh, that's a great question." Let me say this. I don't think that anything in our current range is a perfect drop-in for CPE, but we are continuing to look at what is available that can meet some but not all of the requirements of a CPE jacket. So with that in mind, I would ask the writer to contact us directly and let's talk about their application to see if there is a solution that we might have that checks many of the boxes.
Very good. Will the 89504 material be flexible enough with a 90 durometer hardness?
Yeah, so it is typically cable designers formulate with the insulation, which is a thinner layer, being a bit harder to protect the conductors and the jacket being a softer layer. A 90 hardness doesn't mean that it's going to crack when you bend it, far from it. It just means that it's a little stiffer as you bend it. We do offer an insulation grade with an 83 Shore hardness as well, which is also UL recognized. So, there are other options. This particular one we like because it has really good wet electrical properties. But just because it's 90 doesn't mean it's not going to be adequate for insulation. It is still very flexible depending upon the thickness that it's used at, but we do have a softer insulation available if that's what the customer would like.
Is the 89504 both used as insulations and jackets?
We have seen instances where people have used this as a jacket. There's nothing to contraindicate it other than it's not UL listed for 720 hour as a jacket, so they would need to do their own testing for UV, where, many of the other jacket compounds that I spelled out are UL recognized, I should have said, recognized for 720 hour UV. But there's no inherent reason why this would not be a good jacket choice.
Good. Would the 9602 72 FR be a good choice for a TC-ER rated FT4 with VW1 XHHW conductors?
So as long as the XHHW is VW1, it may be a good choice. We would want to talk about the specifics of the number of conductors, the conductor size, how sometimes when you go to smaller conductors, it becomes more challenging to pass the burn. In some cases, we might recommend stepping up to the 9605 or the 9618. And we do have some other jacket compounds that have even higher LOI and they give up a little bit on the brittleness temperature. But as far as the TC and the ER, yes, these are good choices. We might even look at one of the EVE compounds, the 961580, just because it's a little harder, depending upon the construction as well. But generally speaking, let's talk about the specific application, and we can give you a sense for what we think gives you the best chance of passing all of the tests. But the VW1 XHHW really does help. And then we're working on formulas that might be able to help even if it were not VW1, but those are still in the future.
And again, relative to PVC, classic PVC compounds, do Flexalloy PVC-based solutions of elastomers have any enhanced chemical resistances compared to commodity PVCs, and how would they be characterized or tested the same or differently?
Yeah, that's a very good question. I mean, one of the things that's interesting about PVC, I say it all the time, it's so versatile. A lot of the PVC is pretty good chemically resistant as a resin. And it's when you soften that with plasticizers and other additives that you sometimes create pathways where chemicals can attack the material. So many PVCs are excellent against chemicals if formulated properly. What the Flexalloy gives you in general is a broader temperature range along with the excellent chemical resistivity. So I would say that don't count PVC out for chemical resistance just because it's not a Flexalloy. But if you really want a very broad range of properties and chemical resistance, then we're talking the right kind of product line here.
Very good. What 720-hour jacket might you recommend, broadly? And one thought is the 9602.
Yeah, exactly. I mentioned it as kind of a workhorse product. We sell a lot of it. It's used in a variety of applications. Some I haven't even listed here, like, different kinds of umbilicals and stage lighting cable and things like that. It's probably a good starting point candidate. And I might even suggest the new product that I just talked about, which is intended to overcome some of the raw material shortages, which is named similarly 5960272FR.
Okay. Just in general, I know it's a different topic, but is Teknor offering PVC color concentrates again?
That's a great question. So our color division recently acquired Lanier color concentrates in Georgia. So they are part of the family, and they do offer PVC color concentrates. I don't have great expertise on their capabilities right now, but I do know that was part of their original business as we acquired them.
And I would suggest if you have interest in that, then you reach out to the Teknor Apex team and get more information on that.
Yeah, thank you, David. I'd be happy to make a referral as well.
That's fantastic. And as we begin to wrap up here, if you have any last minute questions, please enter them in the chat. Which grade of Flexalloy compound might you recommend to replace CSP or PCP type materials?
I'm not sure I know what those are.
And I'm not either, so I don't know what the clarification is for that. But again, what I would suggest is if you ask that question, to reach out directly to Teknor Apex and get an answer. With that, David, I don't see any more questions. So again, I want to thank you sincerely for taking the time and bringing Teknor Apex's perspective to elastomers. And so for those of you who would like to learn a little bit more from Teknor Apex, kindly contact David here. Let me just bring this up. Hopefully, David, can you see your contact points here?
Yep,
Are they correct?
it is there. Yep.
Excellent. Okay, so note the contact points here. Should you wish to contact David or anyone else at Teknor, he will help facilitate that for you. Just to wrap up, I'd like to simply say that each of these IWCS webinar series presentation events are recorded, and we will archive them on our website or from our website. So please check it out again if you want to review the presentation again. The IWCS webinar series will conduct our technical paper presentations along with our industry trend webinars, as well as some sponsored company events several times per month. Our next scheduled technical paper presentation webinar event will be next Friday, June the 17th at 10:30 a.m. Eastern USA time. Each of you will be receiving an announcement for that event, so please feel free to share our announcement with your colleagues so that they can join in and register as well. Are there any last minute questions that I can't see right at the moment, David or Becky?
I don't see any, Dave.
Okay, excellent. Well, thank you for your engagement, for all the attendees today, and some excellent questions for David. It's important that we all recognize and thank our industry partner sponsors, including Teknor Apex, who contribute greatly to the success of our Cable and Connectivity Industry Forum. Without their strong leadership and generosity, we would not be able to bring these important technical innovations and information to you and our global community. Again, thank you to these leading suppliers in our industry and for your important support for the technical innovations in our industry. For over 70 years, IWCS has presented the Cable and Connectivity Industry Forum, and we are the recognized leader showcasing technologies in cable and connectivity products, processes, and applications. Thank you, David, for bringing that attention to us. With perseverance and confidence, we are all very excited to conduct our 71st annual Cable and Connectivity Industry Forum, taking place in person on Monday through Thursday of October 10th through the 13th in 2022 at the Rhode Island Convention Center in Providence, Rhode Island, USA. Please watch your inbox, social media, and our website to learn more as this exciting information becomes available. Please visit our website at iwcs.org for more event details. If you want to participate as well as an exhibitor or sponsor, we certainly would love to hear from you. Again, thank you for participating in today's event, and this concludes this webinar event. Thank you so much. Have a great rest of your day.
Appreciate it.